Hello everybody, welcome into another lesson. So today we are going to talk about the number e. Well, what is the number e? If you look up here at the top, you see e is approximately equal to this big hulking number, has a bunch of digits, and then it doesn't stop. This is only an approximation for it from the calculator. Just like a number like pi, it's non-terminating and it's non-repeating. It just keeps going on and on forever and ever. Well, why does e matter? It's considered the natural base. It's often called the natural base. And it's used for continuous growth or decay. So, unlike with other exponential numbers, like if you have a whole number or even a fraction, those usually happen in steps, where e is used for continuous growth or decay. It's often called Euler's number because Swiss mathematician Leonhard Euler was the one that discovered this number. It's approximately equal to 1 plus 1 over n to the n power. So what that means is, for every number you keep putting in and raising it to that same power, it comes out approximately equal to e. It's continuous growth. It continuous growth or decay. E we approximate usually if it's 2 decimal places as 2.72 or 2.718. That's usually what we say. We're not going to write this whole thing for the number e, but I just wanted to show you how big it really is. So why do we care about e? Well, when you go on to take pre-calc and calculus and even differential equations and higher, this number comes up all the time. We'll even need it in this course. And it's used heavily in the sciences, heavily. It's used even in accounting and the financial fields. It's used in so many different areas. So this is a good number to add to our repertoire to expand our knowledge of numbers. So we're going to do a couple of examples on the calculator. So yes, if I take e to the first, or just e, we can say it's approximately equal to 2.718. We'll round to 3 decimal places, right? So e is approximately equal to 2.718. Now, let's say I did e to the third power. What is e to the third approximately? So put that into the calculator here. And there should be an E button in your calculator. Pretty much every calculator has them. I've never seen one that doesn't. E to the third is approximately 20.086. So about 20.086 is what you would get if you evaluated e to the third power. 20.086. And then what if I did e to the negative third? So I take e to the negative third power. Well, that's equal to, of course, 1 over e to the third power. So let's do a decimal approximation for that. 1 over e to the third. So 1 divided by that. Alright, you get approximately 0.05. That's about what it rounds to, approximately 0.05. So it's like taking any other number to a power, only it's e. I don't think anyone has a hard time understanding that. It's just like any other number, really, only it's e this time. Okay. And let's say, hypothetically now, I'm going to do it with any other number. You have 2 to the second times 2 to the fourth. What do? you have the same base, so when you multiply two numbers of the same base but different exponents, right, you just add the exponents. That'd be 2 to the 6th, which as we know would give you 64. But what if we did it with e to the 2nd times e to the 6th? Well, it's the same, e to the 2nd times e to the 4th. It's just going to be the exact same process. That, of course, would give you e to the 6th, which now we'll get a decimal approximation for that. So everything you do with normal exponents, you can do with the number e. It's just a number. That's all it is. Just a hideous number, but it's a number. So e to the 6th is approximately equal to 403.429. Yeah, so e to the 6th is approximately equal to 403.429. That's what you would get. Then, of course, we could take e to the negative 3rd times e to the 5th. Well, again, you're multiplying the same base. You just add the exponents. So negative 3 plus 5 is 2. So this would turn into e to the 2nd power, which we can get a decimal approximation of that easily. Let's figure out what e to the 2nd is. That'll be easy. 7.389. So e is approximately equal to, e squared is approximately equal to 7.389. Now let's do a little bit of algebra with it. We have 3e to the negative 3x raised to the negative 1st power. So we have 3e to the negative 3x raised to the negative 1st power. Well, according to properties of exponents, you can split up the two bases. This would be the same as 3 to the negative 1st power times e to the negative 3x to the negative 1st power. Well, what's 3 to the negative 1st? That, of course, is 1/3. And then e to the negative 3x then to the negative 1st, you multiply the powers. This would turn into e to the 3x. So literally, you would just end up getting e to the 3x over 3. And that would be your answer. That would be the best way to simplify this. E to the 3x over 3. Easy enough. We have 3e to the 4x raised to the 2nd power. So 3e to the 4x raised to the 2nd power. Well, 3 to the 2nd, of course, is 9. Then you take that e to the 4x, raise that 4x to the 2nd power, multiply the powers, you would get 9e to the 8x. So this would simplify into 9e to the 8x power. Let's see, e to the x times e to the negative 3x times e to the 5th. So we got 3 bases of e that we're multiplying. Well, you're just going to add all 3 powers together. So what's x minus 3x? That'd be negative 2x. So this would be e to the negative 2x plus 5, which also you could say is e to the 5 minus 2x. You could write it either way. Either way would be correct. This would be e to the negative 2x plus 5 power, or e to the 5 minus 2x. And you would have your exponential function, and the graph of e to the x looks almost identical to 2 to the x or 3 to the x or any other function. Alright. The square root of 4e to the 2x. Now we have the square root of 4e to the 2x. Well, that's the same literally as the square root of 4 times the square root of e to the 2x. Well, what's the square root of 4? That's going to be 2. Square root of e to the 2x, well, that's literally just going to be e to the x. So this would simplify into 2e to the x. All right, let's see. 5e to the x divided by e to the 5x. So we have 5e to the x over e to the 5x. Well, the 5 stays in the numerator, right? You'll have 5 in the numerator, but since the power in your denominator is greater than that of the numerator, the power on e is going to favor the denominator. So 5x minus x is 4x. So this can be written one of two ways. You can write this as 5 over e to the 4x, which is acceptable. Or you could also write this as 5e to the negative 4x. You can write it either of those ways. You'll get 5 over e to the 4x, or you could write it as 5e to the negative 4x. Either way, it's the same thing. It's just how you're writing it. Do one more here. Let's take the cube root of 64 e to the 9x. So I'm going to take the cube root of 64e to the 9x. Well, again, this will split up into the cube root of 64 times the cube root of e to the 9x. Alright, so what's the cube root of 64? That's 4, right? What's the cube root of e to the 9x? Well, that'd be e to the 3x. So this would simplify into 4e to the 3x power. So really it's pretty simple. It's just a funky number, but we got to get used to it, especially if you want to go into more advanced math and go into science and engineering and other things. E is going to come up all the time. So that's it for this lesson. Next lesson we're going to talk about compound interest problems, which heavily involve exponential growth as well as using the number e. We'll get into a couple formulas for compound interest and do some practice problems. So I hope everyone has a great day. Take care.